Our next topic is about series and parallel connection. In this circuit, we have a battery and we have a lamp. The circuit consisting of just one element is very simple to analyze, but it's not often found in practical applications. Usually we find circuit where more than one components are connected together. The question is, how can we connect more than one components in a circuit? Fundamentally, we have two ways to connect electrical components together. They could be connected in series and look like this, and they could be connected in parallel and look like this. Let's start by series circuit or series connection. The defining characteristic of series is that the components are connected one after the other in a same row, in the same line. So let's now imagine the current, the flow of the current. The current comes from the battery, flows in the circuit to reach the first lamp, then continues his path to reach the second lamp, then flows back to the battery. So there is only one path to the current. The current has only one path to flow in the circuit. The current remains constant everywhere in the circuit. This relationship is called law of uniqueness of current in series connection. Law of uniqueness of current in series connection. It means that all electrical components receive the same current. The intensity of the current is the same any point in a series connection. Now, how can we speak about current and not speak about voltage? Let's speak about voltage. In a series circuit, the voltage of the battery is shared between all the components. To explain this slide, I will move to this one. To know what happens to voltage in a series connection, we want to cut up this circuit into pieces. يعني this from P to N, it will be PA, then AB, then BC, then CN. So the voltage UPN, يعني the voltage across the battery, will be equal to the voltage UPA plus voltage UAB plus voltage UBC plus voltage CN. As we know that PA represents a connecting wire, so the voltage across UPA is equal to 0. AB is the voltage across the lamp. I don't know this value, so I leave it as it is. BC represents the voltage across the second lamp. I don't know the value, so I leave it. CN represents the voltage across the connecting wire. The voltage across a closed switch. And I know that the voltage across a closed switch is equal to the voltage across a connecting wire is equal to 0. So my equation becomes like this. UPN equal UAB plus UBC. What the meaning of this sentence? The meaning is in the voltage across its component. Yeah, if I add plus the voltage across the first lamp and the voltage across the second lamp, the answer, the sum of these voltages will be equal to the voltage of the battery. So here I add, عشان هيك اسمه law of addition of voltage in series connection. So this means that the sum of the voltages across loads mean components, is equal to the voltage of the battery. But if I want to speak about current, the current remains constant. Law of uniqueness of current in series connection. To explain this note, I will come back to this slide. What happens to current in other lamps if one lamp in series circuit burns out? If I disconnect this lamp, or this lamp turns off, or breaks down, or burns out, شو بصير لباقي السيركت? If this lamp turns off, this means that this circuit, this part of the circuit will be open. So my circuit become an open circuit. Open circuit means no flow of current. So this lamp will stop working. This is a weak point of series connection. In a series connection, if a lamp breaks or a component is disconnected, the circuit is broken and all the components stop working. كمان weak point تاني على series connection. If I turn on a lamp, all the components will turn on. يعني إذا بضوي شغلة الكل حيضوي، إذا بتطفي وحدة الكل حيطفي. This slide will give you a summary about series connection, law of addition of voltage in series connection, and law of uniqueness of current in series connection. Now let's move to parallel connection. What the definition of parallel connection? If components يعني means lamp, battery, motors share two common terminals, they are in parallel. شو يعني هالحكي؟ Terminals means ends, extremities. Yeah. The terminals of this battery are P and N. The terminals of this battery are A and B. Since PA represents a connecting wire, then ما في voltage. I know that the voltage across a connecting wire is equal to 0. So the voltage across UPA is equal to 0. Remember, the voltage represents the difference. And the voltage across the battery represents the difference between the extremities of the battery. If the difference between P and A is 0, then B is identical to A. Sorry, P is identical to A. Same for N and B. And B represent a connecting wire. I know that the voltage across a connecting wire is equal to 0. So N and B are identical. So the battery and the lamp share two common terminals. So the battery and the lamp are connecting in parallel. Same for these two lamps. Each device is placed on its own separate branch. The current is divided into more than one path. I will talk in detail later about this point. So in this example, B and A and C are identical لأنه connecting wire كلهم سوا. N و B و D كمان identical لأنه connecting wire كلهم سوا. So my figure becomes like this one. The lamps in this figure are connected in parallel. خلينا نشوف. This P and this A are identical لأنه between P and A we have a connecting wire and the voltage across a connecting wire is 0. But here between N and B we have a lamp. So N is not identical to B. So this battery and this lamp are not connected in parallel. Now we want to talk about laws in parallel connection. The first law in parallel connection concerning the voltage say that in parallel circuit the voltage across the terminal of all branches is the same. يعني the voltage across the battery. Remember that the voltage itself doesn't go anywhere. The voltage مش بيمشي بالcircuit. The voltage represents the difference between the extremities. طب بما أنه عندهم نفس extremities, so the difference between their extremities equal. يعني the voltage هون is equal to the voltage here is equal to the voltage here. So this law is called law of uniqueness of voltage in parallel connection. Let's talk now about currents. In this slide, I sent from the generator. Generator means battery, means dry cell, the source of the electricity. Reach this point, and at this point, it splits into different portions. It divides up into I1 and I2. I1 flows in the first path يعني first branch and I2 flows in the second branch. In this point the I1 and I2 are recombined to form I and flow back to the battery. So in parallel connection the current of the battery, the main current of the battery is the sum of the currents through each path. This law is called law of addition of current in parallel connection. يعني أنا كأنه بعكسهم. بالسيريس we have a law of uniqueness of current, addition of voltage. بالparallel law of uniqueness of voltage, addition of parallel. This table will sums up the parallel connection, law of uniqueness of voltage in parallel connection, law of addition of voltage and of current, in parallel connection. This note will be explained in details in this slide. What happens to current in other lamps if one lamp in a parallel circuit burns out? شو رأيكم؟ شو رح يصير؟ In a parallel circuit, if a lamp breaks or burns out or a component is disconnecting, the component in other branches keep working. لأنه الكرنت رح يوصل لهون. Oh, it's an open circuit, but I can continue my path to reach the second lamp. So all the components in the circuit will keep working. A question crossed my mind. How are the electrical appliances connected in a house? In series or in parallel? Suppose that are connected in series. For example, imagine that our refrigerator and a lamp were in series. The refrigerator will run only when the lamp was on. لأنه نحن أخذنا بالسيريس if one lamp turns on, all the component will turn on. If one lamp turns off, all the component will turn off. So if I want to run my refrigerator, I should turn on my lamp. And when the bulb means the lamp burns out, the refrigerator would stop working. It's not logic. Imagine that your house is wired in a series circuit. What would have to happen if you wanted to watch TV? You have to turn on other appliances. لأنه إذا قلنا بالسيريس one component turns on, all the components will turn on. Stupid, right? So different electrical components or appliances in a domestic circuit are connected in parallel because if one electrical appliance stops working due to some defect, all other appliances keep working. Each electrical appliance has its own switch ضوية لحالها وبطفيها لحالها. And each electrical appliances get the same voltage. بتلاحظوا التي في عندنا 220 فولت، الواشينج ماشين 220 فولت، كله 220، كله same voltage لأنه connecting in parallel. Thank you.